Okay, so let's do a couple more examples with addition and subtraction. So the first one is going to be very similar to what we did before. So let's go ahead and try to simplify all of these terms. So let's take out an m from here. Sorry, m squared. So if I pull out an m, what's left over is 2m because 3 divided by 2. Here, the 50 is really 25 times 2, so I can pull out a 5. I can also pull out 2 n's, so n squared, and the m stays the same. Well, the 50, I pulled out a 25, so there's a 2 left over, and an m. And then lastly, 18 can be broken down into 9 times 2, so I can pull out a 3. So this is minus 9. I can pull out n squared, and then 1m. So what was left over from here, I was 9 times 2, so there's only a 2 left. This one got pulled out, and I'm only left with a single m. So now again, remember, all the things that they have in common is all the variables, right? So what I could do now is just add the constants by themselves. So negative 9 minus 10 is negative 19. Negative 19 plus 2 is negative 17. So this is equal to negative 17 times that variable change, which is n squared m square root of 2. That's it, done. Now, the second problem can be very complicated. When what you should do is, right, you look at the thing that we're doing, which is addition. And what do we do when we add two fractions? The thing that we did was we found the LCD, and then we added the top and kept the bottom. Now, if you do that right away, you'll get the right answer. But if you notice that the LCD here is fairly ugly, right? It's this 5x squared square root of 3x part. So what you should do is deal with this fraction by itself first and see what you can simplify offhand. So here, I'm going to leave that left-hand side alone. And then I'm going to simplify the right-hand side. So the 40 divided by 5 is going to give you 8. The x to the third divided by x squared, we subtract the exponent, so I just get a single x. The last part, right, so the orange is the part that I did over here. And then the blue part, what can I do with those two, right? I can write it as a single square root. So I'll write it as a square root, 150x squared divided by 3x. And then now we can simplify that blue part even more. So this is equal to 7 square root of 2x cubed plus 8x. That blue part, 150 divided by 3 is going to be 50. And then the x squared divided by the x gives you a single x. The square root of 50, we already did before, which was 25 times 2, so I can pull out 5. So 5 square root of 2x. There's going to be a 8x in the front. And here I can pull out an x, right? Because the division by 3 is going to give you the 2 with the remaining 1. So 7x square root of 2x. And now notice that they have the same variable part in common. Okay. So what I need to do on that right-hand side to make it look proper, so maybe it'll help you see it a little bit better, is write this as 40x square root of 2x. So hopefully that'll help you see that these parts are in common again. So if we have that all in common, we can add or subtract the constant terms. So the constant part here is the 40 and the 7. Will give you 47. And then the rest stays the same. Now this common part, right, can be true for other looking types of examples. And so I'll just do a really quick example where it's something like 7 root 2 plus 40 root 2. Okay? There doesn't have to be variables in there. You can simplify this one because they still have something in common, which is the root 2. So I can factor that out. And then in the parentheses goes whatever was left over, just the 7 and the 40. So in total, there are 47 square root of 2's. There doesn't have to be a variable there as long as they have something in common. You can factor it out, add the constant or subtract the constant terms.